Hey, this is a video for 6D, the box and whisker plot. So your objective is I can create and interpret a box and whisker plot. Okay, so we're going to start off with how to create the box and whisker plot. And we need some vocabulary to do so. So our first vocabulary word is minimum. Minimum is the smallest value in the data set. Okay, next we're going to look at median actually, and then maximum, and then we're going to come back in and take a look at these two. So the median, middle value in the sorted data, and we've done this before. You just put all the data in order and then find that middle value. And then the maximum, biggest value in the data set. So now we have the smallest, the biggest, and the one right in the middle. So what is the first, or sometimes called the lower quartile, and the third, or the upper quartile? The lower quarter, so 25% of the data. And the way we're going to find this, we're going to have to actually find the LQ, is we're going to find the median of the lower half of the data. So we're going to find the median of all the data, and then we're going to find the median of the lower half. All right, if that's the first, lower quartile is the lowest quarter, then the third or upper quartile, this is going to be greater than 75% of the data. So how we find it, how we find this one number is find the median of the upper half of the data. So that's going to make more sense as we get into this. Let's go ahead and look at this. So we are given the life expectancy of males and females of several different countries. Okay, and we're just going to focus on females. So create a box and whisker plot for the life expectancy of females in these 14 countries. Okay, so I broke this down into steps for you. So our first step is to sort the data from least to greatest. Okay, so I went ahead and did that for you just as a time saver, but you're going to want to be very organized about this when you do this because I won't always provide it for you. But you would go through and look for the smallest number here. So there's 40, and you would write down 40. And then you'd cross 40 off your list. And then you'd go through and look for the second smallest number, and there it is, 43. So you'd write down 43 and cross 43 off your list, and so on until you have all of your numbers in order from smallest to biggest. All right, so now we're going to make the 5 number summary. This is something that I'm going to have you do. Lost my place here. With this data, so you're going to find the mean, the minimum, the maximum, the medium, and then this LQ is just the lower quartile, and the UQ is the upper quartile. And then if you forget how to find those, well, that's why we wrote it at the top. It says find the median of the lower half of the data, find the median of the upper half of the data. Okay, so there's a few things about doing this correctly that we need to be careful of. Start by finding the minimum and the maximum because that's pretty easy. Our minimum is the smallest number. When we have it in order, it's easy to find. Our maximum is the biggest number. And then we just need to find our median. So I'm just going to knock off numbers from the top and bottom until I get to the middle. Just like this. You can do the same and see if you can come up with the median. All right, so right here, because I have an even number of numbers, the median is in between these two. So I would have to find the mean between these two numbers. Well, 80 plus 80 divided by 2 is going to be 80. So our median is 80. So notice, and actually let's take this out. At this point, you probably know that you need to find the mean. So let's take that out. So our number is 80. Okay, so I pull that out. And now I need to find the lower quartile. Now when I find the lower quartile, whatever the median was, I'm going to not use that in finding this. Okay, and that's going to be obvious when I have an even number of numbers, less obvious when I have an odd number of numbers. So we're going to take a look at that in just a second. But for the data that we're working with, let's now do the same thing for the lower half. Okay, so this is our lower half of the data. Lower half or lower 50%. And this is going to help us find our lower quartile. So I'm going to go ahead and cross my numbers out again until I get to the middle. Okay, this time I do have a middle number there because I have an odd number of numbers. So this is 75. And now let's go ahead and do the upper half. The upper half is going to give us the UQ, or the upper quartile. So this is the upper half. And I'm going to cross my numbers out. And I get 82. Okay, I have all my numbers now. Before we move on to actually creating the box plot, I want to show you something. Because in this case, we had an even number of numbers and we had to find the mean. But it's a little bit different when you have an odd number of numbers. So note, if you have an odd number of numbers, don't use the median when you go to find the LQ and the UQ. Okay, so in this case, this has nothing to do with this problem up here. I just want to show you another quick example just to interrupt this process for a moment, because this is going to come up. So I'm going to go find the median here. I have this, 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 this. The median then is 9. Okay, so now I want to break this up into, I'm actually going to circle the 9 or box the 9. Right, that's the median. So when I go to figure out my lower and upper, this is the lower and upper 50%, and now I need to cross out in here. I'm not going to use my 9, so I go boop, boop, and that means I get 5 for the lower, and here I get 14 for the upper. Okay, so if your number is within your data, you're not going to reuse it when you go to count. If your number is something that you have to find the median for, then these two numbers here will be used when you go to count for your upper and lower quartile. Okay, so we have our numbers here. So now let's actually make the plot. Okay, step 3, create the box and whisker plot. So make a number line. The numbers be spaced appropriately. And what that means is, let's not draw a random number line down here with numbers just placed on it all over the place, willy-nilly. If you have, if you're going up by 5s, then there should be an equal distance between each of the numbers. Here's my number line. I'm going to draw a bunch of tick marks, and I am going to go up by 5. That's not always the best. It just depends on your situation. So when I go to draw my tick marks, I want to have about even spaces between. I'm not going to draw this and then all of a sudden draw one right next to it like that. I'm trying to get them as close to even as possible. I suggest using graph paper or a ruler to do that. So go ahead and create your number line. And as I'm going along here making my tick marks, I also want to think, well, how far do I need my number line to go? And if you look back on the previous page, our minimum value was 40. So I want to go at least to 40. I might even go a little bit lower. So I'm going to go to 35. Okay, but I don't need anything lower than that because it's just going to squish up what I'm doing over here. So 35, 40, 45. Okay, so I've got all this in here. And now looking at my data, my biggest number is actually just 87. I don't need to go any further than this. Okay, so that's going to happen sometimes. But you need to kind of figure out what you need to do or how far you need to go and then edit it as you do it. Here we go. So I have a number line, and these are relatively evenly spaced. I didn't use a ruler for this one, but I don't have major differences between how this is spaced. And I'm going up by a certain increment. So I'm going up by 5s. And now I'm going to go to my next step here, which tells me to draw a short vertical line above the number line at each of the numbers in the 5-number summary. So I did those numbers on the front of these notes, but our minimum is 40. So that means I'm just going to draw a vertical line above 40 here. Change colors. Just like that. And I'm going to do that for each of my numbers. So I have 45, then I have 75, then I have 80, I have 82, and you want to be careful when you go to do 82. Well, 82 is not halfway. It's a little bit less than halfway. So 82 is right about there. And then 87, again, 85, 86, 87 is right about there. Okay, so it should make sense with your number line. And if you space your number line well, then it'll work out. All right, next part of the step is draw a box from the LQ number to the UQ number. Okay, so remember, this is our minimum. This is our LQ. This is our median. This is our UQ. And this is our maximum. So when it says draw a box from LQ to UQ, it's going to be right here. So let me go ahead and draw that in. There we go. Now we're going to draw whiskers to connect the box to the maximum and the minimum. So our whiskers go to a certain spot. We're just not randomly drawing them out there, but they're actually going to go from the minimum to our box, or the lower quartile, and from our maximum to the upper quartile. There we go. All right, so very important to make this correctly spaced. Otherwise, if you just randomly draw in your 5 numbers and then connect it, you won't get the proper shape of the box and whisker. And we want to actually see something when we're looking at this. So we can kind of interpret the data just by looking at our graph. Okay, there's something you should know about this. The way this is spread out, each of these parts here are by 25%. So this is 25% of the data right here. This from here to here is 25% of the data. And from here to here is 25% of the data. And then lastly, from here to here is also 25% of the data. Hence why we call these quartiles. Okay, so you can see that at 75 here, 75%, it just so happens that it falls at 75, but 75% of the data is ages 75 or above. 50% of the data is ages 80 or above. So we're seeing that a lot of people mostly live to 75 or bigger or 80 or bigger, okay, as opposed to their, let's take a look at the front here. Which country had a very low life expectancy? 40, so Angola is a very low life expectancy, but in most countries people live to 75. It looks like 75% of the population lives to 75. All right, so now we're going to be given a couple of box and whisker plots, and we're going to interpret some things from it. Okay, so we have a couple of vocabulary words for this. We have the range. This is the difference between the maximum and the minimum. So just looking back up here again, this would be 87 minus 40. In the case above. So let's actually write that down. So if we want to find the range of this range, we would have 87 minus 40. Okay, the interquartile range would be the difference between the upper quartile and the lower quartile, which covers 50% of the data because we have 25 and 25. So the interquartile range, we would be taking, let me look back at my numbers here, 82 minus 75. Okay, so we have here's 82 and here's 75. That would find the range here. So 82 minus 75. So a couple of words for you. And now let's take a look at these stacked box and whisker plots we have here. So box and whisker plots are a great graphical representation when you want to compare two sets of data, because you can plot them all on the same number line and kind of get an idea of how the data compares to each other. So in this case, we're looking at average daily temperatures for each month of the year in 3 cities. Okay, so we're comparing Tucson, Seattle, and Boston. So we can kind of see just by glancing at it that Tucson clearly has hotter averages than Boston and Seattle. And then we can also look deeper into it. So I'm going to ask we have a few questions to answer here. There's all kinds of ways that we could interpret these box and whisker plots, but we're just going to answer these questions right now. So what is the median temperature for each city? So the median is still this number right here. So we can actually pull numbers straight out of here. So for Tucson, we can see that our median is 70 degrees. For Seattle, well, our median, we're going to kind of guesstimate here, but to me it looks like it's at 52 degrees. And then the median for Boston is 49 degrees. So if we're just looking at the median temperatures of these 3 cities, we would say, well, Tucson is really hot, or much hotter, let's say, much hotter than Seattle or Boston, which are relatively similar, right? So just looking at the median, you're going to think that Seattle and Boston are pretty similar. But looking at the spread here or the range, they're actually not that similar, right? They have a median that's pretty close to each other, but the range is different. So which city has the largest range of temperatures? Well, clearly not Seattle. That seems to have a smaller range. But let's go ahead and find out Tucson, what the range is there. So if I want to do Tucson, I would have to subtract. Looks like the hottest temperature is 90, and the lowest temperature, I'm going to call that 53. So subtract 53. And that would give me a range of 37. Okay, but I don't know that that's the biggest range. Let's see if Boston, just by eyeballing it, it kind of looks like Boston's bigger, but I don't know for sure, so I'm going to go ahead and do the math to find out. So for Boston, looks like our maximum is 72, and our minimum there looks like 26. So when I subtract the two numbers, I get a range of 46. So it does turn out that Boston would be the answer to this question. It has the biggest range of temperatures. It gets hotter in the summer and colder in the winter. Okay, so what is the highest average temperature for Seattle? So we're just looking for the highest temperature there. Well, right there, the highest temperature for Seattle looks like it gets 65 degrees for average. So we can conclude that the summer months in Seattle, the average is 65. All right, half the months in Tucson have an average temperature above what temperature? So if we're looking for half the months in Tucson and we're looking for above, we're looking for the upper half, right? So remember, this is 25% and this is also 25%. So together, this would be 50%. So we're looking for the 50% that's above what temperature? Well, it looks like that is above 70 degrees. Which city has the mildest temperatures? And when we say mildest temperatures, we're usually thinking not extreme temperatures, right? So Tucson's getting pretty hot here in the summer. It gets an average of 90, which means it goes above 90 sometimes. And Boston gets pretty cold. It's down to, looks like about 26 degrees on average. So Seattle has the mildest. It doesn't really get too far below freezing very often, looks like, and doesn't get much higher than 70, right? This is the average, so probably has some hot days, but on average, we're only at about 61. So I'm going to go with Seattle. Okay, there you go. That is your video. I'll see you in class.